Viewers, and welcome back to the final maths class. The questions on the board, these 3 questions, were sent to me by one of my followers from Botswana, who is in the person of Portia Palai, and she's asking me for the solution of these questions. Okay, now the question looks very simple, but all you have to apply here is the laws of indices and then certain basic mathematics principles. Okay, so if you know those things, this question will be very simple. But when you look at them and you don't know the laws of indices and then the basic mathematics principles, you will look at it and then see that the question is very tedious. Look, you see this question is very simple. It looks very short and simple, but if you don't know the basics, you are going to find yourself fumbling with the solution of the question. So without wasting my time, we'll go straight to the question. Now the first one is x to the power negative half equating to 1/2. Okay, now the first thing that you have to do is to make sure you get rid of this negative at the power. All right, so by so doing, you just have to somersault this x. So 1/x. You put it in a bracket, then raise to the power what? 2. Here you have gotten rid of the negative power at the exponent, okay, equating to 1/2. All right, so from here, this power half means that we have a square root over here. Okay, so this is what it means, 1/x. This is what we have here. All right, which is equal to 1/2. So to get rid of this power half, you have to square root the 1/x, and then you have gotten rid of what? The half at the power. All right, so we can also change this and bring it back to here. So from here, we can separate these two and write it as square root of 1 over square root of x equal to 1/2. All right, so from here, square root of 1 is 1, and then square root of x, we don't have any value, so we repeat that one, the same thing. So here is where the basic mathematics comes. Okay, here you have 1 over square root of x equating to 1/2. We can somersault this. Okay, since it is an equation, we can somersault here and do the same thing at the other side too. So with equation, whatever that you do at one side, you do the same thing at the other side too. Okay, so what we do is we can somersault this, or we can reciprocate 1 over square root of x to have what? Square root of what? X equal to, when we somersault this one too, we have what? Just 2. All right, so in order to get our x here, all we need to do is to square both sides of the equation. Okay, so this square will get rid of the square root here, and it will left with x equal to 2 to the power 2 will give us what? 4, and this will bring us to the solution of this question. So quickly, let's move on to the next question, which is x is equal to 7 to the power 0 times 9 to the power half times 4 to the power minus 1/2. So we have x here. We are looking for the value of x. So x will be equal to, we know that in maths, 7 to the power 0 will give us 1. Any number at all to the power 0, or any variable to the power 0 will give us what? 1. So you have 1 here times. And then we have 9 to the power half. Just like we introduced square root here when it was to the power half, we can do the same thing here and write as what? Square root of 9 times 4 to the power half here too. We can reciprocate the 4, all right, to get rid of the half over there. All right, so here we have 1/4 to the power 1/2, just like we reciprocated here to get rid of the negative at the power. Okay, we do the same thing here over here too. So now x will be equal to 1 times, now square root of 9 is a perfect square, so it will give us what? 3 times, over here too, we can put square root over there. Okay, so it will be the square root of 1/4. All right, so x will be equal to 1 times 3 times square root of 1, and then over square root of what? 4. Okay, so from here we have x to be equal to 1 times 3 times square root of 1 will give us 1 over the square root of 4 will also give us what? 2. So the solution to this problem is 1 times 3 will give us 3. 3 times 1/2 will give us 3/2, and this will give us the solution of the question. Now, The last one is x to the power 3 over 2 equating to 1 over 27. Okay, so the first thing that you have to do, you realize that all that we've been having, if you have a negative power, the first thing that we do is to get rid of the negative power. Okay, so this one is no different to the ones that we solved. So this one, the first thing that we will do is to what? Get rid of the negative power. So over here too, we will reciprocate it just like we did at the previous question. So here we have 1 over x to the power 3 over 2 equal to 1 over 27. All right, so having gotten rid of the negative sign at the power, the next thing that we have to do is to write these powers against the numbers. Okay, so we have 1 to the power 3 over 2 dividing x to the power 3 over 2, which is equal to 1 over 27. Okay, now from here we know that 1 to the power 3 over 2 will give us just 1. Okay, x to the power 3 over 2, which is equal to 1 over 27. All right, so from here we have 1 over this value, and then we have 1 over this value too. So just like we did for this side, we somersaulted this and had it in this way, we'll do the same thing here. Okay, so we'll somersault this and do the same thing here. So over there, when you do this somersault and you do it, you do the same thing over here too at the other side of the equation. There it doesn't affect the power of the value. Okay, because you've somersaulted this side and you somersault this side. But if it were to be this side only that you are somersaulting without considering this side, there it will what? Affect the power of the value. Okay, it will affect the power. But if it's not that way and you are using the equation approach, you are doing the same. What you do here, you do the same thing at the other side of the equal sign. Then you are eligible to do it without affecting the powers of the values. Okay, so here when you somersault, we have x to the power 3 over 2 equal to 27. All right, so now we have it like this. All right, now we can have this as x. We are going to separate this, x to the power half, x to the power 1 over 2 times 3 over here equal to 27. But with the 27 too, we can write it as, with the 27 we can write it as 9 3 to the power 3. Okay, we can have it as 3 to the power 3. So over here we can rewrite this as 1 x to the power 1 over 2 into bracket to the power 3 equal to what? 3 to the power 3. So there's something that I need you to notice over here. In the laws of indices, when we did the indicial equations, we realized that when you have certain things like this and the bases are the same, when you have, for instance, the base a equal to base a to the power y equal to base a to the power x, like this. Okay, since the bases are the same, you can equate what? The powers are also automatically the same. Now the same way, if you have the same different bases, say y and x, and the bases and the powers are the same, okay, you can also what? Equate the bases. Okay, so if you have y to the power a equal to x to the power a, it means that since the powers are the same, it means y is equal to what? X. So the same thing that we have here, we have this base, but the powers are what? The same. So we just equate what? The bases. So x to the power 2 equal to what? 3 over here. Okay, so from here what we do is we have x to the power half, right? And then 3. So what we do is we can change this one to, or we can square both sides of the equations. Okay, we can square both sides. So when we square here and then we also square here, let's see what we'll be getting. When we square here, this 2 will cancel this 2 and to left with x to the power 1, which will give us what? X. So 3 to the power 2 will give us what? 9. And this will be the solution for the question. Now if there's something that I did here that you don't understand, it means you have to go back and refer to the videos that we did on the laws of indices. Okay, you look at the indicial, you could just like I just gave an example here. If you didn't understand this very well, go back to my previous videos on indicial equations and then you will find how to deal with this particular example that I just gave here. And then the laws of indices are what I applied in solving these questions. So this will be to the end of the class for today. If you know you are new to this page, make sure you subscribe to my page, like, and leave a comment. And also make sure you turn the notification bell on so you will be notified whenever I upload a new video. And don't forget to share with your learning colleagues, and have a nice day.